Yes, for oral and parenteral cephalosporins, this side is for oral, this side is for parenteral cephalosporins. So for all cephalosporins, they are hydrophobic. If not, okay, they have hydrophobic part, which is okay, they have more of the hydrophobic parts. If not, they don't have living group, so no living group. So if it has a living group, it should be an ester. Ester at we named this one R3. So it should have an ester. So this hydrophobic part or the lipophilic part enables is a penetration through the membrane into the system. Then this living part, because we said that the living part is catalyzed by the acid. If it's catalyzed by the acid, we shall form a lactam, so which will degrade the cephalosporin, meaning it will be inactive. Then, if it has a living group, it should have ester to compensate for the living group. For example, this structure, this is cephalexin. This is cephalexin. Now, at R3, there is no living group. I think so, meaning that this cephalosporin is stable in the acidity of the GIT, and this side, this group is so lipophilic, meaning that this one is ready to be swallowed here orally. It can be given orally. Now, meaning that now this cephalosporin will target more of the gram positives than the gram negatives because of the hydrophobic part or the lipophilic part than the hydrophilic part. Then this one, there's no living group. So we have a chlorine. This chlorine also increase the hydrophilicity of the drug, and we have this lipophilic. No, it will increase the lipophilicity of the drug, and we have also this lipophilic part, meaning that this drug can be given orally because no living group, meaning it is stable in the acid, and this part is also lipophilic, meaning that the lipophilicity is high. Then, when it comes to this one, it's the same thing. This is cephacla. Cephacla. Then, this one, there's no living group, meaning that same thing with these ones. This cephalosporin. Now, there is hydroxyl part, but the hydrophilicity of this drug is not that so much to hinder the penetration through the GIT membrane, because there is also this part. There's also this part, meaning that this one can be given orally and can penetrate the membrane. So there is a penetration. Is a penetration. Now, when it comes to this one, this group is a living group, meaning that it is unstable in the acid of the GIT. But we have an ester here. We replace the H group with this group. Now, this one is an ester, meaning that it can compensate for this one. So this ester will be stable in the GIT, but when it reaches the plasma, it will be hydrolyzed by esterases, meaning that it can be given orally. So this is cephaloxime acetyl. It's an ester of cephalosporin. Cephalosporin is a parental, but if we make it an ester, it is an oral drug. This is cephalosporin. This is cephalosporin. Now, for parentals, meaning they have living groups. One, they have living groups. If it doesn't have a living group, means that it has poor penetration. Poor penetration through the membrane. Yeah, some they have no living groups, but they have poor penetration through the membrane because of the more hydrophilic parts. For example, we have this structure. This is cephalosporin. It has a living group. Yeah, this group can be hydrolyzed in acid. So this one is not suitable for oral, though it can penetrate, but to be degraded. Then this one, this is cephalosporin. Cephalosporin has a living group. So living groups, one of the living groups we have the acetoxy methyl derivatives, or the acetoxy methyl derivatives are living groups. Another one, it is urethane. Urethane. An example of urethane, this group where the CH3 is replaced by the amine group. So urethane and the aromatic thiols. Aromatic thiols. Aromatic thiols, all those groups which are these ones, the aromatic groups which are bonded by the sulfur group. They are good living groups. They are good living groups. So if you start drug with this structure, means it's parental drug. Then, but now this one, it has a good living group, though it has this structure, but it has a living group. This is cephalosporin acetate and ester, but now this one is the cephalosporin now, which is parental because it has a living group, but there is no an ester. If we put an ester, this ester compensates for this one. This compound, this drug it has this group, means that it is cephamycin. It's a cephamycin. So it is cephalosporin. It is a cephalosporin. So you may find cephalosporin having no living group, but because of these compounds, for example, if you have like this compound, it will be more hydrophilic, meaning that that drug will not penetrate easily through the GIT membrane. So parental drugs, for example, we have cephalosporin, cephalosporin, cephaloxime, cephalosporin. Others we have ceftriaxone. So you see ceftriaxone, you see cefoperazone, ceforadine. So many of them, if you see a living group, then there is if it's not a living group, you find structures which are highly hydrophilic or this R group or this group. So if you find a drug having, for example, these groups, the amino thiazoles, they are highly hydrophilic. So this drug is difficult to penetrate through the GIT membrane. So if you see them, they are all parenterals. Now that's some of the information about the oral drugs and parenteral drugs. Let's go to the spectrum of activity. For the spectrum of activity, cephalosporins, you see, they're like for example, this one, it's like ampicillin. Ampicillin has these groups. Ampicillin, the penicillins. So the spectrum of activity is like that of penicillins, like ampicillin and amoxicillin, for example, this one. But for them, they target more. They have a unique activity against Klebsiella, those bacteria. So they are wide spectrum antibiotics. Now let's go to Pseudomonas. How do you know that this one is Pseudomonas? This group, the alkoxide group, if you see a cephalosporin with alkoxide group, yeah, you find the alkyl group, then you find the oxygen and the amine group. So those alkoxy group are the alpha carbon, which tells that alkoxy amino group. Okay, alkoxy amino group are the alpha carbon. So these groups with the amino thiazoles. So they should be there, both of them. So if it has this group and this group, they have the activity against Pseudomonas aeruginosa, but not all of them. Then this anti-Pseudomonas activity is increased by the presence of the polar group. For example, this one has the carboxyl group. So this one has the most anti-Pseudomonas activity. Okay, this one is ceftriaxone. This one is ceftazidime. Then if you find a cephalosporin having the urido part, this is like remember this group in penicillins, we saw that uridopenicillins, they have these structures. Yeah, they have this structure, the alpha carbon. So this is cephalosporin. It's a uridocephalosporin. Then you find the carboxycephalosporins, they also target Pseudomonas aeruginosa. This one is ceftoxime. So these cephalosporins, they target Pseudomonas. So if you see this and these groups, it is increased by the polar group. Now, for beta-lactamase resistance, I'd skipped it. To be beta-lactamase resistant, these cephalosporins, one, the ring itself is not that strange. The cephem ring. This ring, all of it is called cephem ring. There is a double bond there. It's not strange as in penicillin. So generally, all the penicillins are relatively stable to beta-lactamases, but the extent varies because there is also steric hindrance. So steric hindrance increases the resistance to beta-lactamases. For example, you find this group. The structure is complex, so it resists the beta-lactamase enzyme to break the cephalosporin ring, the beta-lactam ring. Steric hindrance is achieved by this R group and also this group. These groups, they resist the beta-lactamase to reach the beta-lactam ring. Another thing which increases the resistance to beta-lactamases, for example, those cephamycins, which have the alkoxy group here, the OCH3. So this alkoxy group at position 7 also increases the resistance. Increases the resistance to beta-lactamases. Another thing, apart from that, alkoxy group. Okay, this methox. Okay, specifically this is methoxy group for cephamycin. Methoxy, it's a methyl group. Then alkoxy group at alpha carbon. These groups, they increase the resistance to beta-lactamases. That's why these cephalosporins, they target that Pseudomonas aeruginosa, so that they are not easily cleaved by beta-lactamases and they have higher penetration. They can penetrate because of the polar groups. These polar groups, meaning that also the alkoxy at position 7. No, at alpha carbon increases the resistance because it increases also the steric hindrance. Then steric hindrance by all the structures, the complexity of the structure increases the resistance to cephalosporins, to beta-lactamases. So they increase the resistance to beta-lactamases. Now let's go to generations. Yes, mostly for generations, cephalosporins are put in generations according to the period of discovery and also the substrates which were modified. For first generations, if you see, mostly we on the changes are on R2 group, which is this one. We have R1, 2, 3, and 4. So at R2, there is a methyl group. If it's not a methyl group, it is acetoxy-methyl group. We saw acetoxy-methyl group. If it's not, it is 1, 3, 4 diazo, this group. So this group, it's there in cephalosporin. So in generations, they are increasing the potence mainly they target to increase the potence, increase the spectrum, increase the resistance to beta-lactamases. Now, you see this group and this group, they are good living groups, meaning that these drugs with these groups, they are not given orally. So they have no oral administration. So they are given parentally. But this one can be given orally, but it is targeting more of the gram-positives. So they are increasing. In generations, they are increasing all these ones. Now, when you come to this one, substituting the methyl group with a chloride group, we are increasing the potency to be more lipophilic. So you see the cephalopora with chlorine. So if you see, we have a double bond in R2. For example, cephalosporins, it has a double bond. They are meaning that this one we are changing it to a non-living group, so it cannot easily be hydrolyzed by esterases. Cannot easily be hydrolyzed by esterases and other enzymes. Then thiotetraazoles, these groups, at R2, this group is different from this one. This is a diazole. These are thiotriazoles. It's a tri. Oh, they are tetraazoles. The thiotetraazoles. Yeah, they have 4 nitrogen atoms. So this one will be like this. Yeah, to be like that. Thiotetraazoles. Then urethane. So this group is a living group, but compared to this one, to the acetoxymethyl group, this one is a living group, but comparing this one to this one is less living than this one. Then urethane, for urethane is CH2. So they are replacing the methyl group with amino group, meaning that this is an ester, so it is cleaved by esterase, but this one will not be cleaved by the esterase. So they are increasing the penetration of that drug and resistance to the acidity of the stomach, because so that living groups, they are cleaved by the acid increases their cleavage. So in second generation, we have chlorine, we have a double bond, thiotetrazole and urethane. Then for third generations, we have, so this one and this one, we are dealing with the R2. But for third generation, mainly we are dealing with R1. At R1, we have the 2 amino thiazole. We saw the 2 amino thiazole. So these groups at the R1. Then also alkoxyl group at alpha carbon. For example, those groups, the alkyl group, we have oxygen, nitrogen. So these groups in third generation, all those ones, if you see them, they are under third generation. At R1, so all those mainly the antipseudomonas there under third generations. The antipseudomonas, they are third generation cephalosporins. Those self-triaxone, cephaloperazone, ceftazidine. So the cephalosporins, for example, cephaloperazone, we saw that structure. It's under third generation. Then for the fourth generation, they retain the structure of the third generation, but they have a quaternary ammonium group, cephapine. They have the quaternary ammonium group, but they retain the structure. But this is at R2. Then for the fifth generation, we have this. It retains the structure of the third generation because the structure is retained even in the fourth generation, but they alter these groups. So this cephalosporin is under the fifth generation. It has capacity to bind to those abnormal penicillin binding proteins because of its structure, and also the normal ones. So this one will mainly can target the methicillin resistant Staphylococcus aureus. It can target these because it can bind to those abnormal penicillin binding protein like penicillin binding protein 2A. It can also bind to penicillin binding protein 2X. It can also target the Streptococcus pneumoniae. So it is called cephalosporin fosamine. It is cephalosporin fosamine. Now, about the side effects, side effects of cephalosporins, the presence of this group, the MTT, methyl thiotetraazole. So this group it's like this. So this group, if you find this group on cephalosporin, it is responsible for the disulfiram effect. It's responsible for disulfiram effect and also bleeding disorder. So all those cephalosporins having this group, they can lead to these effects. So another thing, side effects of cephalosporins, it's due to concentration in urine, so they can lead to nephrotoxicity. Hypersensitivity to cephalosporins is very low compared to penicillin, so they also have some hypersensitivity effect. So those are the main side effects of cephalosporins. But these two are due to this MTT, the methoxytetrazoles. Then the esters, we talked about the esters, that esters, they increase the oral availability of the drug. If here we substitute this hydrogen with an alkyl group or another group form an ester, meaning that we are increasing the oral availability. For example, in cephalosporin acetyl, we saw it. It's one of the esters. Yes, thank you for watching. Please subscribe, like, share the videos. I'll bring more.